Our universe is vast. It is filled with countless stars and potential worlds. We look up at the night sky and dream of visiting them. But there's a problem, a very big one. The distances are almost unimaginable. The nearest star system, Alpha Centauri, is over 4 light years away. That means even if we could travel at the speed of light, the journey would take more than 4 years. To truly explore the cosmos, to become a truly interstellar species, we need to find a way to travel faster than light. This isn't just a desire for speed, it's a fundamental necessity for humanity to reach out and touch the stars. A brilliant mind, Albert Einstein, gave us a new understanding of the universe. He showed us that space and time are connected, forming a fabric called space-time. He also gave us the famous equation E equals mc squared. This equation tells us something profound about speed. It says that as an object with mass gets closer and closer to the speed of light, its mass increases. This increase requires more and more energy to keep accelerating. To actually reach the speed of light, an object with mass would need an infinite amount of energy. The universe, it seems, has a cosmic speed limit, and it's the speed of light itself. It's a fundamental law of physics as we have long understood it. But what if we've been thinking about the problem in the wrong way? What if the solution isn't to travel through space faster, but to change space itself? A new way of thinking, called quantum physics theory, invites us to look at energy and speed differently. It suggests that the energy of an object isn't just about how fast it's moving from one point to another. Instead, it also depends on the density of the space field it is traveling through. Think of it like swimming. Moving through thick honey requires much more energy than moving through clear water, even at the same speed. This theory opens a new door for us to explore. This new perspective doesn't break Einstein's laws, it simply adds a new layer to them. The speed of light remains the ultimate speed limit for anything traveling within the fabric of space-time. But quantum physics theory proposes that we might be able to manipulate the fabric itself. Instead of trying to push a spaceship faster and faster against an impossible energy barrier, we could perhaps find a loophole. The theory suggests that we can alter the properties of space around the ship. This is not about brute force. It is about understanding the very nature of space-time and using that knowledge in a clever new way. It's a shift from being a passenger in the universe to becoming its pilot. So how could we possibly manipulate space-time? The answer lies in a concept straight out of science fiction, but one that is being seriously considered: the warp drive. A warp drive engine would not propel a ship through space in the traditional sense. It wouldn't use rockets to push against anything. Instead, it would create a warp bubble completely enclosing the spaceship. This bubble would be a localized region of space-time that has been distorted. The ship inside the bubble wouldn't actually be moving at all relative to the space immediately around it. It would be at rest, comfortably and safely protected from any strange effects. This warp bubble is the key. The warp engine would work by compressing the fabric of space-time in front of the ship. At the same time, it would expand the fabric of space-time behind the ship. Imagine you are standing on a small rug. To move across the room, you could bunch up the rug in front of you and then stretch it out behind you. You haven't taken a single step, but you have moved across the room. The warp bubble does something similar with space-time itself. The ship rides this moving wave of distorted space, like a surfer riding a wave on the ocean. The wave moves, carrying the surfer with it. The incredible part of this idea is that while the ship inside the bubble is stationary, the bubble itself can move through space at extraordinary speeds. Because it's the fabric of space-time itself that is moving, the cosmic speed limit of light doesn't apply in the same way. The bubble is not an object with mass traveling through space. It is space itself that is flowing. This could theoretically allow the bubble and the ship inside it to travel from one point to another faster than a beam of light could make the same journey. It's a clever way to sidestep Einstein's rule without ever breaking it. This concept changes everything we thought we knew about interstellar travel. We are no longer limited by how much fuel we can carry or how powerful our engines can be. Instead, the challenge becomes about how effectively we can manipulate the space-time around us. It requires a new kind of technology, one based on controlling the very geometry of the cosmos. The energy required would still be immense, but the theory provides a path forward. It gives us a blueprint for a future where journeys to other stars are not the stuff of dreams, but a real possibility for future generations of explorers. Even with the promise of a warp drive, there are challenges to overcome. One of the biggest is gravity. Here on Earth, or even within our solar system, we are deep inside a gravity well. A gravity well is a region where the fabric of space-time is already significantly curved by the mass of a planet or a star. This curvature creates what we call gravity. It also means the local space field is very dense. Trying to create and move a warp bubble in such a dense environment would be incredibly difficult. It would be like trying to start a speedboat in a sea of thick mud. It would require an enormous amount of energy just to overcome the existing distortion. Think of it like this. Space itself has a kind of resistance. Near a massive object like Earth, the density of the space field is high. This density acts as a drag on our warp bubble. The energy needed to compress and expand space-time is much greater here. This is why a warp drive might not be something you just switch on to pop over to the next town. It would likely be a technology that works best once you are far away from the strong gravitational influence of planets and stars. It is a technology designed for the vast open ocean of interstellar space, not the crowded harbors of a solar system. But once a ship travels out into the void between the stars, the situation changes dramatically. In deep space, far from any significant gravitational sources, the fabric of space-time is much flatter. The space field density is incredibly low. Here the resistance is minimal. The same amount of energy that struggled to create a tiny distortion near Earth could now generate a much more powerful and efficient warp bubble. The ship would be able to maintain its speed with far less continuous energy input. It's like a car that has finally left the bumpy city streets and is now cruising on a smooth open highway. This difference is crucial. It means that interstellar journeys would likely begin with conventional rockets, pushing us out of our solar system's gravitational grip. Only then, in the quiet emptiness of interstellar space, would the warp drive engage. The ship wouldn't have to constantly fight against gravity's pull. It could dedicate its energy to sustaining the warp field that carries it toward its distant destination. This understanding helps us plan for what a real interstellar mission might look like. It would be a two-stage process, first escaping our cosmic neighborhood, and then truly beginning the faster-than-light journey. So we have our ship in deep space and we've created a warp bubble. How can we go even faster? The theory suggests a fascinating possibility: stacking warp fields. This means creating not just one bubble around the ship, but multiple nested layers of them. Each layer would create its own distortion of space-time, building upon the effect of the layer inside it. Think of it as putting a smaller, faster wave on top of a larger, slower wave. The combined effect could be much greater than what a single field could achieve on its own. Each additional warp field layer would contribute to the overall effect, compressing the space ahead and expanding the space behind more dramatically. The first field might get you to 10 times the speed of light. Adding a second layer might not just add another 10, but could multiply the effect, perhaps taking you to 100 times the speed of light. A third layer could amplify it even further. This is not just simple addition, it's a compounding effect. The physics becomes about how to create and sustain these multiple, stable layers of warped space-time around the vessel. It's a complex engineering challenge, but one that is theoretically possible. This stacking concept is what could truly unlock the galaxy for us. It could be the difference between a journey to a nearby star taking decades and a journey that takes only months or weeks. It would allow us to explore not just our immediate stellar neighbors, but to venture out into the spiral arms of the Milky Way and beyond. The ability to control the level of speed by adding or removing warp field layers would give interstellar pilots incredible control over their journey. They could navigate the cosmos with a precision and speed we can currently only imagine. The possibilities are breathtaking. This new way of thinking about warp drives, gravity, and energy provides a beacon of hope for the future of space exploration. It tells us that while Einstein's speed limit is a real and fundamental part of our universe, human ingenuity might find a way to work with the laws of physics to achieve the impossible. The path to the stars will be long and filled with challenges, but theories like this show us that the journey is not barred to us. We just need to be clever. We need to keep questioning, keep exploring, and keep dreaming. The cosmos awaits.